Okay, fine. So I think some questions we have solved. How many questions we have solved in the previous class?
That's in fourth question in exercise 10.6.
Exercise 10.6, fourth question. Now fifth question of the exercise 10.6. So question number 5. Now prove that the circle drawn with any side of the of a rhombus. Prove that the circle drawn with any side of a rhombus as a diameter passes to the point of intersection passes through the point of intersection of its diagonal. Prove that the circle drawn within side the rhombus, okay, as a diameter with any side of the rhombus, any side of the rhombus as diameter. Now what we'll do, first we'll draw a rhombus. So let's say this is the rhombus. Okay, just first let me draw the shape. This is a circle. Okay, let's say there is a circle, or we'll so this is the circle, let's say. Now this is the center of the circle. This is the side of the rhombus, any one side of the rhombus. So remaining side we have to draw like this. This is the second side. This is the third side. This is the fourth side. Right. Now we have to prove that it will pass through the point of intersection of its diagonal. So diagonal of the rhombus will be like here. So this point, the point of intersection of the rhombus, the circle is passing through it. Okay, that's what we have to prove. Completed till here?
Yes, sir.
Now first thing what we have to do is, first thing we have to draw, we have to name the points. First let's say this is A, this is B, This C and this D. And the point of intersection of the circle is O. The point of intersection of the circle is O. Let's say center, no need to name center. Now ABCD is a rhombus, we already know. Okay. Now proof we will go for. Angle AO. AOB. Now if we will see, it is a rhombus and diagonals of the rhombus bisect each other at 90 degree. So this point 90 degree, this point 90 degree, this is also 90 degree and this is also 90 degree. First thing we know, these all are 90, 90, 90. These AOB, AOC, sorry, AOB, AOD, DOC, BOC, all those points 90, 90. Just a sec. Someone is. Okay. Now these all diagonals, as we already know, the diagonal bisect each other. Diagonal of a rhombus bisect each other at 90 degree to each other. Okay. Now AB is diameter. AB is a diameter. Since AB is diameter, diameter, and therefore angle in the semicircle must be 90 degree. So at a circle also the angle must be 90 degree. So this point must lie on the circle only, right? Right? Because angle in a semicircle is 90 degree. So I'll write it properly with the statement. It is a theoretical question, so no need to worry about it. Angle AOB is equals to 90 degree, we already know. Diagonal of the rhombus bisect each other. Since diagonal of the rhombus bisect each other at 90 degree. Okay. And AB is a diagonal and AB is a diameter. AB is a diameter. Now angle in a semicircle, and angle in a semicircle is 90 degree. Angle in a semicircle, semicircle 90 degree, a right angle. Hence see, this point is 90 degree as diagonal bisect each other. So this is angle in a semicircle only, because this AB is a diameter. It is given in the question that AB is a diameter. Then only any point, at any point, if it will drop on the circle, that angle will be 90 degree, as we already know. Angle in a semicircle is always 90 degree. That we already know by the theorem. So hence circle will pass through the point of intersection of the intersection of the diagonal of the rhombus, diagonal of the rhombus. Note it down.
Yes, sir.
And C. Intersect. Intersect. CD. Produced if necessary. Produced if necessary. At E. Prove that A equals to AD. Prove that AE is equals to AD. Now, A, B and C, 3 points are there on the circle. A, B and C. So let's say A point is here, B point here. Okay, we will mark A here, B here, C point here. Okay, and D point, let's say somewhere here. So D point somewhere here, and we will produce D point to E. Produce if necessary. It is required, produce it. Now, what they are asking, AE, A to E, this is the distance, AE is equals to AD, this distance equals. Now we already know that in a triangle, side opposite to equal angles are equal. We know that, right? So if we will be able to prove this angle and this angle are equal to each other, we can say that these two sides are equal. Okay. So major target is to prove that these two angles are equal. Automatically it will be proved that the sides are equal. So we'll do that. Let's mark the angle. We know, let's say this is angle 1, this is angle 1, let's say this is angle 2, let's say this part is angle 3, and here angle 4, angle 5, and angle 6. Now in a parallelogram, opposite angles are equal. It means that we know we know ABCD is a parallelogram. If ABCD is a parallelogram, opposite angles are equal. Opposite angles are equal, which means that angle 3 is equals to angle 4. And we already know angle 3 plus angle 1 is equals to 180 degree linear pair. Angle 1, angle 3, it is making a straight angle, a linear pair. Angle 1 plus angle 3 is equals to 180 degree by linear pair. So let's call it equation number 1. Now let's call it equation number 1. Let's call it equation number 2. As we can see that ABCE is a cyclic quadrilateral. ABCE and ABC and E is cyclic quadrilateral. Cyclic quadrilateral. I will write full spelling. Quadrilateral. So ABCE is a cyclic quadrilateral. Opposite angle of a cyclic quadrilateral are sum of the opposite angle of a cyclic quadrilateral is equals to 180 degree. Angle 2 and angle 4 is a cyclic quadrilateral. Angle 2 plus angle 4 is equals to 180 degree. These two opposite angles, sum of the opposite angle of a cyclic quadrilateral 180 degree. Let's call it equation number 3. Right? We remember in mind that we have to prove that angle 1 and angle 2 is equals to are equal to each other. Angle 1 and angle 2 are equal to each other. Now as we can see, angle 3 is equals to angle 4. So equation number 2, substitute equation number 1 in equation 2. Substitute equation 1 in equation number 2. So it will become angle 1 plus angle 4 is equals to 180 degree. Angle 3 equals to angle 4. We have substituted, instead of angle 3, we have substituted angle 4. And we also know that angle 2 plus angle 4 is equals to 180 degree. Now do one thing, subtract these two equations. This is equation number 3 already, and let's call it equation number 4 after substituting. Now subtract equation number 4 and 3. So this negative, positive become negative, positive become negative, positive become negative. 180 degree to 180 degree cancelled. Angle plus 4, angle minus 4 cancel. So angle 1 minus angle 2 is equals to 0. Means angle 1 equals to angle 2. And in a triangle ADE, angle 1 is equals to angle 2. Hence AD is equals to AE. Side opposite to equal angles are equal. Since side opposite to equal angles are equal. Understood?
Yes, sir.
Okay, note it down. Hopefully completed till here. Now, question number 7. And question number 7, what they are saying is AC and BD are the chord of a circle. AC and BD are chords of a circle which bisect each other. Which bisect each other. Prove that. Prove that. Part 1. AC and BD are diameter. AC and BD are diameter. Part 2. ABCD is a rectangle. ABCD is a rectangle. Two chords which bisect each other. They are saying that. So let's say the point of intersection of the chord is O. Let's say the point of intersection of the chords O. Sorry. Let's say this is a circle. Okay. Now if two chords bisect each other means if they are intersecting, two chords are intersecting, then this part equal and this part equal, right? So we are assuming that these two are bisect each other. So bisect means it will be possible only if the chords are diameter only. So let's say O is the center. Here I will draw AB. Sorry, AC is one chord, and here O here, and B B and D. I can draw it better. Just a second. Okay, now let's see. If there is a center here, O, so if I will draw first diameter like this, and the second diameter here like this, BD, AC. These diameter bisect each other. Now we will join A point and B point. We will join B point to C point. See, now it will be a AC and BD. Now these two chords becomes the diagonal of ABCD parallelogram, because parallel diagonals of the parallelograms only bisect each other, right? Am I correct?
Yes, sir.
So ABCD becomes a parallelogram if AC and BD are the chords which bisects each other, and if we will join ABCD all points, ABCD all points, so AC and BD are the diagonal of ABCD which bisect each other, means ABCD is a parallelogram and which is inside the circle. Okay. Now we have to prove that AC and BD are the diameter. So how we are going to? We have drawn the diagram by considering it itself. So by considering that AC and BD are the diameter, but will how we are going to prove it? So proof. Now in a triangle, we will take two triangles first. Okay, triangle ABO and CDO. A B O and C D O, opposite this triangle and this triangle we take in triangle ABO and triangle CDO. Now diagonal bisect each other. Diagonal bisect each other. These two chords bisect each other. So we already know that OA is equals to OC. So this AO and CO both are equal to each other. We can say AO equals to CO. First thing. Now second thing, these two also equal, BO and OD. This BO and DO equals to DO. Now, since these two are the lines which is intersecting each other, this angle and this angle will be equal to each other. Right, angle AOB is equals to angle. So, angle AOB is equals to angle COD. Vertically opposite angle. VOA property. And this is given in the question itself. It means that triangle ABO and CDO are congruent to each other by SAS congruency. Triangle ABO is congruent to triangle CDO by SAS congruency. By SAS congruency, correct? Now by CPCT, what we can say? Any angle we can prove equal because both sides are equal. So AB is equals to CD we can say, which is already ABCD is a parallelogram. ABCD is a parallelogram, so AB equals to CD anyway. So that is no point. Opposite sides are equal in a parallelogram. And since diagonal bisect each other, ABCD diagonal bisect each other, it means already opposite AB and CD are equal to each other. So angle, any angle. Alternate interior pair angle if we will prove, then AB and CD, these two, we will say angle BAO is equals to angle BCO by CPCT, corresponding part of congruent triangle. Now AB is parallel to CD, ABCD is a parallelogram. That's all. AB equals to CD. Alternate, there is alternate pair of alternate, AB equals to CD. We already know that ABCD is a parallelogram, but still we are saying. Note it down. Similarly, we can say, similarly, these two, by taking these two triangle, we can say AD, AD is equals to C is AD is equals to BC. Also we can say ABCD is a parallelogram. ABCD is a parallelogram. We have already learned the shortcut that it is a parallelogram. We already knew, but still we are proving it. If ABCD is a parallelogram, then we can say sum of the and ABCD is a cyclic quadrilateral also. Not only it is a parallelogram, it is a cyclic quadrilateral also. It means sum of the opposite angle is equals to 180 degree, as well as opposite angles are equal to each other. If ABCD is a parallelogram, we know that angle A is equals to angle C, angle A is equals to angle C, as well as angle A plus angle C is equals to 180 degree, which means that angle and 2 times of angle, instead of angle C, this is equation number 1, this is equation number 2, substitute equation number 1 in equation number 2. So angle A plus angle A is equals to 180 degree. So 2 times of angle A equals to 180 degree, angle A is equals to 90 degree. Now angle A is 90 degree as per the, now if BD is, we already know if BD is a diagonal, sorry, just a second. If BD is the diagonal, BD we have drawn like this, and A here. If BD is here and this is angle AC, if this is 90 degree and this lies on the circle, means BD is a diameter. Since A point is on the circle, and is, and angle A is 90 degree and angle A is equals to 90 degree, hence BD is the diameter. By theorem, angle in a semicircle, in a semicircle, correct. Similarly BD, if BD is, and similarly we can say angles B is also, if you will prove angle B is equals to 90 degree, same way, because ABCD is a parallelogram. So now this angle B and angle D both are equal to, both sum of both angle is equals to 180 degree, and angle B is equals to angle D, because these ABCD is a parallelogram. Substitute it there. So angle B is equals to 90 degree. If B is 90 degree, this angle is 90 degree. So AC is a diameter. So AC and BD both are diameter. Am I correct? So similarly, AC is diameter. Now angle A is 90 degree, angle B is 90 degree, and angle A equals to angle C and B equals to angle D. So A, B, C, D, all angles are 90 degree. Second part we will prove. Just a second. Completed till here, guys?
Yes, sir.
Now second part also proved by this. How? In a rectangle, all angles are 90 degree and diagonal bisect each other. In a parallelogram, only diagonals bisect each other. In rectangle, all angles are 90 degree also. In a rectangle, sorry, in a rectangle, all angles are 90 degree and diagonal bisect each other. Bisect each other. Now, as already proved above, angle A equals to angle C, angle B is equals to angle D, angle B and angle A equals to 90 and B also equal, angle B and angle D both are equals to 90 degree. So A, B, C, D both are 90 degree. Angle A, B, C, D all are 90 degree. If all angles are 90 degree, and already we know diagonal AC is equals to, sorry, diagonal bisect each other. So AO is equals to OC and AO is equals to OC and BO is equals to OD. OD given in the question itself, it is given that these two chords bisect. Hence, ABCD is a rectangle. ABCD is a rectangle. Proved. Note it down. Completed, guys.
Yes, sir.
Okay. Now, now, question number 8. What they are saying is bisectors of angles A, comma B, comma B and C, B and C of a triangle ABC intersects intersect already intersect its circumcircle at D, its circumcircle at D, comma E and F respectively, and F respectively. prove that prove that the angles of the are triangle DEF is 90 degree. Prove that the angles of the triangle DEF DEF are 90 degree minus half of angle A, comma 90 degree minus half of angle B, comma 90 degree minus half of angle C. Half of angle C. This is the question. Now there is a triangle ABC and they have angle bisector. The bisector of the angles of the triangle ABC is DEF. Make circumcircle, sorry. At DEF. So now first thing, we will draw a triangle. So ABC have a circumcircle. Circumcircle means a circle. Let's say the point A here, B here, and C point here. Okay. ABC, the triangle. Okay. Now let's look at it. Now angle bisector of angle A intersect the circumcircle of ABC at D point. If there is nothing given that whether it is an internal angle bisector or external angle bisector, we will assume only internal angle bisector. Now angle bisector, this is D point. Angle bisector of B is E point. E point. Angle bisector of C. See, do you know about point of intersection of the internal angle bisector? In a triangle, the point of concurrency of the internal angle bisector definition somewhere. Have you heard of it? It is known as in center. Have you heard of in center, guys? No problem. So in future you will study anyway. So these things D, E, F. Now we'll join, because since they are talking about the triangle DEF, we will join triangle D, E, this is the diagram. Okay, this is the diagram. Now they are asking, prove that the angles of triangle DEF is equals to 90 minus half of angle A. Means angle D is equals to what they are asking to prove. To prove, we will see now. Angle D is equals to 90 degree minus half of angle A. Angle E is equals to 90 minus half of angle B, and angle F is equals to 90 minus half of angle C. That's what they are asking. Now we will see, we'll mark the angles what are required right now. Angle required here is, let's call it angle 1, let's call it angle 2. We don't know these two angles are equal or not. Now this part of the angle we will call it 3. This and this equal, right? No need to mark this. This is angle 3 and this half of this part is 4. Let's call it 4. Okay. And since these 4 and this part is equal, so no need to mark this one. Correct? Since you don't know in-center theory, so we are not going to apply any application of in-center. We are going to solve simply. Now, completed till here?
Yes, sir.
Okay. Well, now proof. As we can see, here angle 1, here angle 3, and the diagram is too complicated. Diagram is too complicated. If let's say, if here I will join the chord angle 1, FA, FA if I will join, and it is a single chord. So you can see FA is a chord of the circle, and from FA angle 1 is also there from the chord FA. Angle 1 here like this it is there, right? And angle 3 is also there from FA only, right? This angle 1, angle 3 means this is the angle in the same segment. Angle 1 equals to angle 3, angle 1 equals to angle 3, angles in same segment, same segment are equal. Now angle 2 and angle 4, if you will join AE here like this, angle 2 and angle 4 are equal. Same reason. Angle 2 and angle 4 both are equal. Right. Now we already know angle 4 is half of angle B. We will write like this. Angle 1 and angle 3. Angle 1 is equals to half of angle C. Angle 3 is half of angle C. Angle 2 is equals to half of angle B. Right. So we'll add. Let's say it is equation number 1, it is equation number 2. No. Now add 1 and 2. 1 plus 2. Equation number 1 and equation number 2. Angle 1 plus angle 2 is equals to half of angle B plus angle C. Half common. Angle 1 plus angle C is equals to angle D. Angle 1 plus 2 is angle D. Right? Angle D is equals to half of angle B angle B plus angle C. Now we know that ABC is a triangle. Angle ABC, it is a triangle. So angle A plus angle B plus angle C is equals to 180 degree. Angle A plus angle B plus angle C is equals to 180 degree. So angle B plus C is equals to 180 minus A. Now angle D is equals to half of B plus C. B plus C is 180 degree minus angle A. Now angle D is equals to 90 minus half of angle A. First thing proved. Note it down. Similarly second and similarly third. Similarly we will say same process. Same process what? I will show you. Just a sec. Um, Now if you can mark these angles, let's say here you can mark angle 5, angle 6, and here you can mark as angle 7, angle 8. This is half of angle C. Angle 5 is half of angle C. And you can directly say that from here angle 5 and 7 are equal. Angle 5 equals to angle 7. This and this. And angle 6 by angle in the same segment. Angle 6 is equals to angle 8. Now angle 5 and angle 6. These, so angle 7 is equals to angle 5. Angle 5 is what? Don't go this way. Just a sec. You have to take one angle from this mark. Let's say this 7, 8. This 7, 8. Okay. 7, 8. Now these two angle will say 3 and 6. By these two angle we can say this 7. So now we can say that angle 8 and angle 3 are the angle in the same segment. If we will join this, angle 8 is equals to angle 3 and angle 7 is equals to angle 5. Angle 7 is equals to angle 5. Angle 3 is half of angle 3 is half of angle C. Angle 5 is half of angle A. Right? Angle 8 plus 7, equation number third, fourth. You can mark equation number third, fourth. Add equation number third and fourth. Angle 8 plus angle 7 is angle E. And half of angle A plus C. Half common A plus C. A plus C is 180 minus B. Half 180 minus B, angle B. So angle E is equals to 90 minus half of angle B. Correct? Similarly, understood or not? Understood or not?
Understood, sir.
So see, we proved that angle D is 90 minus A, and we proved that angle E is 90 minus angle B. Now you can do the last one also similarly. Yeah, this part. Note it down till here. If you have any doubt, ask. See, remaining two questions are easy one. 9th and 10th you can try to solve as a homework. Okay. Now,
Okay, sir.
for today that much is enough. The next class, we will start new chapter. What are the chapter pending for us? Now, What happened, guys?
Area of parallelograms and triangles construction.
Area of parallelogram and triangle and construction. Fine. So in the next class, area of parallelogram and triangles we will start. Okay. So we'll conclude today's class here itself. In the next class, we will start the new chapter. Thank you everyone. Class is over now.